The next thing we're going to work on is a centroid, which is the point of intersection of the three medians of a triangle. What is a median? It's the line from the vertex to the midpoint of the other side. So we have already this triangle that we set up when we looked for the circumcenter. And now we're going to use the same one with the same midpoints because we already did all the work. And what we're going to do is we're going to find the centroid, which is the center of mass of the triangle. And just going to, just going to fix this. We had 2 and 5, and so there we have it over here. There we go. There we go. Okay, so what we're going to do is take this from one vertex and then draw the line through the midpoint. I'm going to do the same here from this vertex to the midpoint, and then from this vertex to the midpoint. By looking at this, we know, or it should be obvious, that the y value will be 1 because it's going through right here through all of them. And you'll see, we'll work on this algebraically. And then I'm going to show you an easy trick where you don't really have to find the equation of the lines and then the point of intersection. But let's start with the algebraic method. First of all, in order to get the equation of this line, we need slope and we need the y-intercept. We have 2 points, and we can use that to find the slope, and then use one of these points for the to find the y-intercept. So as you can see here, I started with one of them. So the equation of the median, you take the midpoint and one of the vertex. Now for this first one, as you can see here, right there, this equation here is y equals 1. The slope is 0 and the y value is 1, and therefore that's what we have. That's one of the equations, y equals 1. Okay? With the second one, we have the point 2,5 and the midpoint at 1, -1. Using the slope equation, we've gotten 6 for the slope. So now I can put in my x and my y and my slope. So y is -1, slope is 6. Put in the 1 here, plus b. Bring that to the other side. So this is 6, so -1 minus 6 equals b. And so b is equal to -7. And so our equation of the line is equal to y equals 6x minus 7. So there we have the equation of one line, and we have the equation of the other. Now that's very straightforward, and so all we need to do really to find the point of intersection is to use substitution or elimination, and this one is going to be a very obvious one. We're going to take the y and we're just going to put it right in here. Y is equal to 1. 6x minus 7, bring that to the other side. That gives you 8 is equal to 6x, and divide both by 6. X is equal to 4/3. And so we're going to assume that this is the right point of intersection. It's 4/3 and 1. Now how do I check that? Well, we're going to try and check it in the third equation. So the third equation, we're going to use the point C, which was 6 and -3. And we had this midpoint. And so the equation of this median, first of all, let's find the slope. And that would be a 3 minus 3, and then -1 minus 6. And so the slope 3 plus 3 is 6 over -7. Okay. And always we want the slope and the y-intercept. We now have the slope. We have an x and a y. The y goes here. The slope is 6 over -7 like this. And then we've got here a -1 plus b. 3 is equal to, this is going to be a positive 6 over 7 plus b. Bring that to the other side. And we've got 3 minus 6 over 7 is equal to b. Want to use a common denominator, and so multiply this by 7. 21 over 7 minus 6 over 7 is equal to b. b is equal to 15 over 7. Okay, and now we have both the slope and the y-intercept. Y is equal to negative 6 over 7x plus 15 over 7. Okay, so that's a lot of work, but now what we want to do is plug in our POI. Recall the POI we got was 4 over 3 and 1. We're hoping this is going to work out. So POI, let's write it over here, 4 over 3 and 1. And we're going to plug this in, and hopefully we'll get 1. Y is equal to negative 6 over 7 times 4 over 3 plus 15 over 7. Y is equal to negative 6 and 4, it's negative 24 over 21. We want to change this so that we have a common denominator, which is 21. So multiply by 3 plus 45 over 21. And I don't have much room here, so I'm just going to go here. Y is equal to negative 24 plus 45 is 21 over 21. And that equals 1. So it does work. Perfect. Now, I did tell you there was a little trick in doing this, and I'm going to show you that right now. You're going to like this trick because it doesn't require a lot of work. Basically, to get this point, first let's see if that works. The point is 4 over 3 and 1. Let's look at this. 4 over 3 is 1.3, so I would say that's about here, and 1. So that looks very good. Okay? And another way of doing this simply is to take the average of the 3 points. So the POI, we can take x1 plus x2 plus x3 all over 3, and then y1 plus y2 plus y3 all over 3. And let's see if that works. So if I put in negative 1 plus 4 plus 1 all over 3, and then over here I've got 3 plus 1, 3 plus 1 minus 1 all over 3. I will get 4 over 3 and 1. Negative 1 plus 4 plus 1 gives me 4. 4 over 3 and 1. And there you have it. It worked out. This is much easier, I know, but we do want to see the algebraic way also to prove that actually this works, and there you have it. Okay. Now, I took the midpoints. You don't have to do that. You don't even have to find the midpoints. You can try it also with the 3 vertices. So let's do that right now and see how that works. It's also going to work, let me assure you. So negative 4 plus 2 plus 6 over 3. And then we've got 1 plus 5 minus 3 over 3. And if you calculate this, you will get 4 over 3. Negative 2 and that's negative 2 plus 6, 4 over 3. And 1 plus 5 is 6 minus 3. 3 over 3 is also 1. And it works out. So you could have used simply the vertices, divide by 3, each one, x1 plus x2 plus x3 divided by 3, y1 plus 1. Or you could have used the medians. Okay? So it works for both. And this is called the center of mass of the triangle. And now we'll go to the orthocenter.